All right, so earlier this week I popped in on Lars Christensen's live stream on breaking up CAD, like your design assembly, in order to have individual machining assemblies or environments, so that your design assembly can stay as a design assembly, and you can then push files out into broken up assemblies to keep your CAM in. And this is a pretty important thing, because even on something, at least it's important to me, even on something relatively simple like this that has 5 or so machine parts, if you did all of the programming in here, you'd wind up with something probably around 10 to 15 or so different CAM jobs when you start including custom fixturing and the jobs that get used for that. Not only that, but if you do things like build fixturing that's associated with this pocket clip, because it's probably going to need a custom fixture, you'll have your design tree will start ballooning, right? Because you'll have this component that's for the fixture and all of its stuff, and then maybe some chucks and things that go in here for, or at least like coordinate systems or all of that stuff. And it just starts getting messy. And this is even on a pretty simple project like this. So you can imagine something that's more complex. Even like one of my knives probably winds up with quite a few custom fixtures and quite a few jobs, and there's just a lot of stuff going on in there. And it just gets to be too much to have in one place. It makes it so that you just can't find anything, and it gets to be pretty frustrating. But to me, the most important part of that is that those CAM assemblies maintain a direct and parametric link back to the design assembly, so that changes made in the design assembly will propagate out to the CAM files. So hopefully that makes sense. And I have a way to do this. I think that the solution that came up in Lars's, I'm not sure that it kept that. So I just wanted to show what I've got going on here. So first what we're going to do is we're going to jump into the CAM samples folder. We're going to grab Chuck to use for work holding. We'll just open that up. And the first thing we're going to wind up doing is just saving a copy of this into our project where our design assembly actually lives. So we'll just do file save as. We're going to save this generic 3-jaw Chuck, but we're going to call it advanced mechanism body CAM. We're going to save that in there. Then we're going to go back and into the project, and you can see that's the assembly that we just saved, or that's the file that we just saved, and it's open here still. We're going to grab our design assembly, and we're going to say insert into current design. And all we're going to do is just bring that whole entire thing in here, even though it has a bunch of extra stuff that we don't want. What we want is to be able to maintain that parametric link, and this is the only way to do that I'm aware of. So sort of the issue is that if you do this, if you can save out a copy of individual components in here. You can do save copy as, but that comes out as a broken link, and it doesn't, then any changes made in the design assembly don't propagate out to that individual file. So to me, that's kind of a dead end. By inserting this whole entire thing in here, you can see we maintain a link, and changes made in the design assembly will propagate into this machining assembly. Sort of the problem is you have all of this extra junk that we don't care about, right? But it's not really a big deal. All we're going to do is we're just going to blank out a bunch of this stuff, right? We're just going to hide it. And then we can feel free to add some joints in here. Pick that coin, give ourselves some offset, give it an OK. And there you go. Now we've got our machining assembly with a parametrically linked copy of the part that we want to machine. In here we could make whatever changes we want. We can hop into CAM, we can start a new job and do a setup. We'll say this is a turning. We want to get rid of the 31 bodies because that's everything that's in here, and we just want to grab just the one we want. We wanted to define our Z, and other than that, everything looks pretty good. Then what we'll do is we'll go ahead and we'll throw a quick toolpath on here, and we'll say, let's do a 2D contour, and we'll grab that edge. We need to correct the tool orientation to give us something like that. And we'll come back up here, I think, and click the arrow, and maybe that'll give me what I want. And we'll grab just a 1/16 end mill. We'll say compute, and it's gone the wrong way. try that. All right, so that gives me, it's not perfect, but all I want to do is demonstrate that now we can come in here and say we hop into this profile and we change this to be 0.2 because our design, we realized there was a problem with it and we needed this button to just go flying out like it would now. And so what we do is we hit save because we made a design change. Now when we pop back in here, you'll notice there's some exclamation points. What you need to do is pop back into the model environment. You can right click, got a little bit of a delay, and you can go either get latest here would update it, or there's this nice button here that this just grabs all of the latest files. So if there were multiple files in here that had changes. So now you can see we got some new updated geometry there. If we go back into CAM, it should be as simple, hopefully I didn't test this, but it should be as simple as just hitting regenerate, and now we get CAM that's, you know, actually updated to make the new profile. Obviously that, you know, there's plenty of things you can do that will break that portion of it. If you go in here and you delete this edge, there's a decent chance that it won't be able to, or if you delete the edge that was originally selected as to define that contour, you'll need to go in and redefine that edge and give it a new reference. But in a lot of ways, you know, when you make that selection and it chains, most of the things, you could even come in here and add some new geometry in and it would pick that up as well. So anyway, that's the basic workflow that I use. Usually I don't use the CAM samples library. I have my own templates that I use and bring things in, and they have some more work done in them usually. And I mean, this works for turning, this works for milled parts, it works for everything. What I would wind up with by the time I'm done working on this pen is that I would have, for each machined part, I would have an assembly like this, and it would contain all of the fixturing and everything in the design side of it, and all of the CAM jobs necessary, or CAM setups, I guess is what they're calling them in here, necessary to make the part. And they all stay parametrically linked. Anyway, that's it. Let me know if you have any other questions. Hopefully this is helpful to somebody. I know I struggled with this for quite a long time, and it basically stopped me from using Fusion because I couldn't figure out the answer to this. And since I've started working this way, I've found Fusion to be quite pleasurable to use. This works really well. Anyway, take it easy.